All right, so 2100 or 2102 more specifically, the stop function. How do you want the motor to stop? Two choices, either coasting to a stop, which means that as soon as you press stop, the motor will slow down. And whenever it runs out of energy, that's when it comes to a full stop, or a controlled stop. If you select two, it's a ramp, or it's called ramp. Ramp works with deceleration time, which we'll see next, which means that if you program in decel time 10 seconds, it'll ramp if it was going full speed. Yeah, I kind of drew that the wrong way. Eh? If it was going full speed, it'll ramp all the way down to 0 in 10 seconds. That makes a bit more sense. And I get rid of this. Okay, so it's going 1725 and the decels, or comes to a full stop in 10 seconds. And it could be any time. 10 seconds is just an example. 5 seconds, even 0.1 seconds. If you program it for 0.1 seconds, it'll just stop on a dime, okay? Instantaneously or instantly. All right. So in the 2100 branch, if you will, here, the next number is 2109. So if you look on the right-hand side here, 2109, emergency stop. So I'll call it the E-stop select. You all know what an E-stop is. What does E-stop select mean? Well, if you have an emergency on a conveyor, on a motor, on a machine, whatever it is, and you hit the E-stop, well, the E-stop is not going to be wired with the normal stop. If this normal stop is pressed, well, then that's when the 2102 comes into play with the decel time, which is going to be in the 2200s. But if 2109 is used, it means that it has its own decel time, which could be faster or could be slower, depending on what the generally faster. Okay, so E-stop will be wired to what we'll do, because we want to leave DI1, DI2, DI3, so digital input 1, 2, and 3, to be able to stop, start, and change direction of the motor. DI4 we can use for, let's say, jog. Okay, but although I'm saying here that we're going to use digital input 5, it could be 4 as well, or any other input depending on what we're doing with the drive. Digital input 5. If we're going to use digital input 5, we're going to program it for a 5. So DI5. There's something pretty unique about this. We're going to have to program 2109 if we want to wire it to digital input number 5. We're going to have to program it for a -5. And I'm going to explain why -5. Okay. I'm just going to put 5 because it is wired to 5th input. So we did the drawing last week with start and stop. Let's go to the cutting and pasting here. All right, so have a look at what I just put in here. What I'm saying here is that if I get my 24 volts, I send it to all my push buttons, I have a start, a stop, I have a selector switch, okay? So this would be start, stop with a forward, reverse, using a selector switch. Well, I have an E-stop now, and that E-stop is wired to DI5. One thing I need your attention on is Is it normally closed? Is it normally closed? Isn't e-stop normally closed or normally open? I just gave you the answer. It's a normally closed, right? And if you hit it, it opens. These digital inputs here, what they're monitoring is they're monitoring what to see whether or not there's current going back into the input. Now, if I have a normally closed stop, is there current going back to digital input 5? There would be, right? There's current flowing into it. It sees that as digital input 5 being activated. But since I'm wiring it for an e-stop, I don't want the drive to think that I've activated the e-stop when I'm not pressing it. I want them to activate the e-stop function when I do press it. Okay, it's a little confusing. When we get into PLCs, actually, we're going to talk about reverse logic. So if you remember from your beloved logic circuits, do you remember what this was? It's a NOT. A NOT is an inverter. So what's happening here is by programming it to a -5, what we're doing is we're taking this 1 because it's normally closed, so there's current. We're inverting it so it's not active. Okay, a little bit confusing. This is where we're heading with PLCs as well. So DDs is going to tell me now that if I hit the e-stop DDs, it means that I'm breaking the contact. And if I break the contact, is there current going to digital input 5?
Yes, but then it slows down.
Okay, DDs is not paying attention. Gallo, if I hit the e-stop, it's now open. Is there any current going to digital input 5?
No.
No. So if we were to use the same logic, if it's a 0, but we programmed it as a -5, not a 5, but a -5, that negative represents what? That we're inverting the 0. So if we invert 0, we get a 1, which means that now we are activating the e-stop function. Okay? So we can actually do this with a jog digital input 4 as well. So if ever, I don't know, you're installing something like this and in your truck you don't have a normally open or you don't have a normally closed, you can change the logic and just program it to negative. Okay, you shouldn't do that. An e-stop should always be normally closed. But let's say if you have all you have in your truck is a normally closed contact and you want to use it for a start push button, well, you could. Okay, that's what's going to be cool about programming as well. It's not ideal, but at least you could, right? To dip and aim a little bit. Okay, so let me just redraw that. So it's a normally closed stop. So normally, if you do not press the e-stop, it is a logical 1. Since you programmed it for a -5, it'll invert that to 0, which means that e-stop is not activated, which means that it runs normally. As soon as you hit the e-stop, what happens? There's no more current going into digital input 5. Because you program that as -5, it inverts the 0 to a 1, activates that input, and activates, well, basically what it does after 2109 is activated is it looks into parameter 2208. And in 2208, you're programming a deceleration time. Okay? And in my example, I'm putting 1 second. It could be anything. Okay. So it means that when you press the regular stop, it's a regular stop. Your e-stop is wired in a different input. And once that is active, it goes into 2208 to see how much time you want to stop it once the e-stop is pressed. Do you remember when we talked about the disconnect switch or service switch? We talked about a special auxiliary contact. If you have like a rooftop condenser or whatnot. And I said as soon as you touch the lever, you want to send a signal. Well, you can use this e-stop function as well, because what you don't want to do is cut off the current leaving a drive going into a motor and cutting off the power. What you want to do is send a signal to stop the drive as soon as possible so that before you even have a chance of opening up those blades, there's no more power going to your motor. Okay? Otherwise, you can damage the drive. Questions, or are we good? Okay.
So how does 2208 come in again? Sorry.
So whenever you program 2109, automatically you got to program 2208 as well. What 2208 does, that's where you store the amount of time you want to stop it.
Right, but that's so you're programming it to DI5 as well?
No. 2201, you're basically entering time in seconds. This is basically what you're entering, the 1.
Yeah.
If you want 30 seconds, you're going to enter a 30. If you want 5 seconds, you're going to enter a 5.
Okay, so as soon as like select, like let's say 22, then I find 08, for example, if I have the actual drive in front of me, so
Yep.
I select 22, then opens up the 4 numbers, select 08, and then it'll just automatically go to the time that I would want.
Well, you have to press enter. If you just tap enter, it'll show you what it's programmed for. If you want to change that digit, you either double click quickly, or you press and hold for more than 1 second, and then it's going to flash. So if it's programmed to 5 seconds, the 5 is going to be flashing.
Okay.
And then you can use the up down arrow keys to go to whatever time you want.
Okay.
Good. But they work together. Okay, they work as a set. All right. So speaking about 2200s, okay, so there's quite a bit of cross-referencing because there's always like parameters that work in sets with other parameters. But as you see here, the 2200s are 22s XL decel times. Okay, there's no coincidence that here 2208, the decel time that's right here, starts with the 22. We talked about 22 before for jog. Remember jog? We go back to 1010. Go back to 1010 right over here. It's 1201, a little bit further, 1010. We had 2205, 2206. That's because 2205, 2206 is the XL decel times for the jog push button. So the 2200s are XL and decel times. Let's go back and fill in the information for the 2200s. So this is what you're going to write down. There are actually 5 parameters that we're going to be looking at. 2202, 2203, they work together. This is called set 1. To accelerate or decelerate, generally, or when you want to stop and start the motor. Okay? We've already, I just went back to 1010. We talked about jog. Well, the jog, basically, those numbers up there were 2205, 2206. Now, these are interchangeable, but we're not going to get into that yet. And then we just talked about 2208 now with the e-stop, right? Deceleration time only for the e-stop. Okay. So 2200s, XL decel times. Now, does everyone understand what an acceleration time, deceleration time means? You press start, you have a certain set point. How long will it take to get to the set point? It's programmable. When you press stop, how long will it take to come to a full stop? That's what the decel time is for. So XL decel times work together. All right.
Time 2.
As you write what's on the left there, I'm going to move on. Your 2208 is here, but I've written it down already. We're going to skip and advance all the way up to 2500s, which is critical speeds. Who can remember what the critical speed was used for? Critical speed. Sounds pretty serious. Critical speed, what was that for? what happens with a drive? What does a drive do? A drive changes the frequency, which changes the speed. So if a motor was designed to go full speed and you're using a contactor to control it, but you're modifying it, you're putting in a drive. Well, now the motor can run at any speed between 0 and 60 hertz or 0 and maximum speed. So you're more likely to come across, what was that word? Starts with an R. Resonant frequency, the frequency at which things vibrate or oscillate or resonate, okay? So to offset that, if you look here, it's explained pretty well in the manual. What it says here is that, let's just say as an example, it vibrates between 18 and 23 hertz, okay, as it's accelerating. Well, it's not going to stop within, it's going to accelerate through 18 to 23, but it's never going to stop there, right? Because if it vibrates, you want to avoid it. And then let's just say there's a second set. It also vibrates between 46 and 52. Well, you program a min of 46, a max of 52, which means that it's not going to stay within 46 and 52. So it can stop anywhere in between, but not in between these two groups here. So there's quite a few numbers coming your way now, starting with 2501. So if you don't need it, you don't use it. But if you do need it, what you want to do is activate 2501. So 2501 is basically to activate or enable. So if your 2501 is set to 0, it means you don't have an issue. You're not gonna use any of it. And you can program up to 3. So the next number's coming up. I'll skip a line here. 2502, 2503. As I've written down here, it's set 1. So they work together. Low and high. So you got your low and your high, set 1. Then you got your set 2, also low and high. Then you got your set 3. You don't have to use all 3. You don't have to use any. It's just if it vibrates. Okay. And I've redrawn basically the little sketch here to bypass the frequencies at which the motor would resonate a little bit or vibrate. And it doesn't mean that it's not going to go to 19, 20, 21, 22. It's going to accelerate through it if it's going to a faster speed, but it's not stopping in between for a lengthy period of time. So we're going to come back around full circle with the next set of numbers. And what I mean by that is, like, in your index, the first parameters we spoke about started with 0, 1. But that 0, 1, 0, 2, 0, 1, 0, 3 represented what you wanted this to display. So we're going to go to the 3400s right now. And what the 3400s are basically, what do you want to display when you're running the drive? You want to display the speed in hertz and RPM, not control in hertz or RPM, just display. You want to display amps, the amount of amps, volts, DC bus, internal temperature of the drive, how many hours the motor's been running, okay, completely flexible. So if you see notice on the right, we're at 3401. So 3401, panel display. All right, so how does it work? We've got 3 parameters. We've got 3401, then we've got 3408, and we've got 3415. Okay, so in the 3400s, we've got 3401, 3408 for the second variable we want to display, if we want to display a second variable. And if we want to display a third variable as well, and not at the same time either with the keypad that we have, you're basically using the up-down arrow key to check. Okay, well, you want to see how many amps, how many RPM, or how fast it's going in RPM, I should say, percentage torque. So I'm giving you 3 random examples here. I'm not saying that 3401 is linked to 102. All of these are interchangeable, and not only that, but you've got like dozens of different choices here. Okay, so if I program 102, 102 is basically going to display, once I press start, it's going to display speed and RPM. If I press the up arrow key, it'll display percentage torque because I entered 105. If I press the up arrow key again, it's going to display the DC bus voltage. Does that sound familiar, DC bus voltage? What is DC bus voltage?
Times the square root of 2 or something like that?
It is, yeah. It's basically what the second part of the drive. The first part converts AC to DC, then we have the DC bus, and then from the DC bus, through the IGBTs and the carrier frequency, we generate an output that goes to your motor. Okay. So you can actually display. It's a filter, exactly. Keep watching those videos.
They're awesome.
So I have some encouraging news. We're kind of actually getting toward the end of the parameters already. And there aren't that many left. Okay. No, it's a question of practicing them, but there aren't that many left. So we're going to jump to the 9900s, startup data. And one of you brought this up. I think it was Alex that brought this up. He was saying something about like, how does it know? How does the drive know like what kind of motor, or the speed and poles and all that stuff? Well, it knows because we're going to enter the values. So we're going to go to the 9900s now. And amongst the 9900s are the nominal values that you get from the nameplate of the motor. All right, so we're going to start off with 9902. Right over here, 9902. Application macro. If you remember from a previous lesson, we actually went to pages, I think there were 88, 86, 87, 88, and they had basically a schematic of the different macros, like how to wire them up. Okay? And we said that predominantly we're going to use 3-wire macro. Well, look here, 9902, selection 2 right here is a 3-wire macro. So if we want to simulate a stop-start, most of our labs are going to be using this. We're gonna use a few others afterwards, later on when we start getting a little bit better. And I jumped the gun a little bit because 9901 is actually language. But the funny part about the language is that we have a keypad that basically only displays numbers. So it's not really, language is not that important. As long as you know the decimal system, you're good. I mean, there's a few words here and there, but not much. Okay, so this is another reminder of what 3-wire macro is. What you're doing with 3-wire macro is you're simulating a stop-start. The next one we've done already, so a bit more cross-referencing, if you will. Okay, and I will give you more time. I realize that you need more time to copy, but I'm just showing you that, look, 9904 is not even new. We talked about this already. 9904 is to select between RPM and Hertz. We just talked about conversions, and it's kind of like kilometers and miles an hour, converting from one to the other, telling the drive how fast it wants to go in one of two ways. Yeah. Okay, so if you notice, I'm cross-referencing 2001 and 2002. That's the min and max speed. Talked about it earlier. 2007, 2008. So you can enter in Hertz. You can enter in RPM. It all depends. You choose, but you have to choose in 9904. If you choose a 1, it'll go to 2001, 2002. If you program A3, which is Hertz, it'll go to 2007, 2008 to see what speed you want to go to. And by the way, if you want to choose a jog speed, it's going to prompt you. Who can tell me what the actual parameter was for jog speed? Now, this is why your index is good and useful. Get used to it. Okay, it's going to seem smaller every time you use it. Get comfortable with the numbers. Try to find jog speed. What was the parameter?
1208.
1208. So what that means is that when you go to 1208, it's going to prompt you for a speed. So if you've chosen 1 here, you're going to enter a value in RPM. If you've chosen 3 here, you're going to enter a value in Hertz. Okay, so the constant speed are linked to this 9904 as well. Okay, so if you're choosing 9904.1, you're entering everything in RPM. If you're choosing 9904 Hertz, you're choosing Hertz. I may kind of give you some values in Hertz and RPM, and then you're going to have to convert. That's why I gave you the formula for converting. How are you doing, Christopher?
I'm taking notes.
Are you done with the 9902?
I am. I'm on 9904.
Hey, Christopher, don't you think Didi's is doing a pretty good job of pretending he's writing stuff down?
I am writing, sir.
There you go.
Doodling. Not bad, not bad. 1 page. We're on page 7, but it's okay. I'm watching, man. I'm watching. Okay, so now we have nominal nameplate. So here, I'll put a little bit of a header here. And the header will be motor nominal nameplate values. So the next 6 or so parameters are just basically going to be very easy. You're gonna go to 9905 and 6 and 7 and 8, and you're gonna write down what the nameplate information is. So you guys have already wired up this motor. What's the voltage for this motor? You've read the voltage already with your starter procedure. Your motor is rated for and then there was silence. 208 volts. 208 volts. Okay. Nominal current. Anyway, it's all on your nameplate. Then there's 9910. 9910 is ID run. So drive will identify its own characteristics. Okay. We're gonna get to a code 2025. So every once in a while, it's gonna do like something called a first start. And you're gonna hear like the motor wanting to turn, but it won't be turning. If you see a 2025, you just wait. Every time I hear that or see that 2025, I'm going to exaggerate what it's for. So you remember Don't panic. Just wait. 2025 is basically the first start. It's basically performing like a diagnostics. And after about 15, 20, 30 seconds, the motor will start. Okay, so this stuff here is easy. I don't know if you guys like game shows, but what I have a show, a little show or a little game mimicked from Jeopardy, but mimicked only for the double Jeopardy part. You're gonna have to know what these numbers are for, so you're gonna have to study them, and then we're gonna split the class in 2 or 3 depending on how many you are, and you're all gonna take a turn coming up to the front where I'm gonna have a number, and you're gonna write down what that number is used for. We're gonna have the Jeopardy music going just to stress you out a little bit, and then we're gonna, at the end, we'll see how many points the teams have, and you can bet. You can bet or risk as many points as you want. And the good news is the winner gets bragging rights. Or if you guys want to maybe wager a little bit of coffee or donuts or whatever, that'll be good as well. Did I give you enough time? Is everyone done?
Just 3 more seconds.
That's a very precise amount of time.
Yeah, same here. I'm just on 9908.
3 seconds for you too?
I'll probably need 6. You know my notes.
Yeah. I could use them. So that's it for the parameters. That's not it for all the numbers you're going to learn today, because we have the drive actually gives us codes when there's a fault or an alarm. And then there's fatal codes as well, as we'll see, which basically means that we need to change the drive. But here are some of the faults that I want you to write down. So on page 258, we've got 2004, 2023, 2025. Now, these are not like, they're faults. Doesn't mean much. It just means that you're probably doing something that is a bit of a contradiction. Like you're pressing reverse, but you didn't program it to go in reverse. You have it on forward only. Or you have it on remote start, but you're pressing the local push buttons, or vice versa. Okay. I'll give you a few minutes there, and then I'll go through them in more detail.
Sorry, can you explain 9910?
Yeah, 9910 is basically if you want the drive to basically identify its own characteristics. So you go to 9910 and it performs what's called an ID run. So through magnetism or whatnot, I'm not sure exactly how it does it, but it's able to identify its characteristics. So I'm going to go to the faults in parallel so you can follow. Okay, so if we look here, starts on page 257. So fault tracing. Oh, one interesting little tidbit here is that you can't really reset the drive. Okay? We will when we get to instrumentation. Like there is a factory default, but there isn't one with this ABB drive. And even when I was in the field, it's like if you make a mistake and touch something, it's a bit of a pain. Okay, especially if it affects the way the drive functions. There's like a minor reset, but it doesn't really change like a whole lot. Okay. Won't tell you what that minor reset is yet. So if everyone's done, so this is where the faults are. So 2001 overcurrent. I didn't write them all down. 2002 over voltage, 2003 under voltage. 2004 I wrote down because it's common. Okay? Direction lock. If you remember from the last course, we talked about 1003, which is direction. You choose. Do you want it to go forward only, reverse only, or both? Well, there could be a conflict there, like I said before. If you're pressing reverse, but in 1003, you just said forward only. Okay? So it basically gives you a code. It doesn't tell you directly, you're being a ding dong. What are you doing? So 2004, that's what you're looking for. So 2006, 2007, 2008, not very common. Okay? So I'm going to give you all the more common ones. It doesn't mean it can't happen. It just means that these are the ones that I'm not going to discuss. Seldomly happen. Motor temp, actually, I'm not going to write it down, but it has happened. Okay. Generally, if the fan is not cooling itself properly, or if it's running at a low frequency for a long amount of time, so motor temperature is too high or appears to be too high due to excessive load, insufficient motor power. Okay, you don't have to write it down though. So 2004, we're going to jump to 2023. Okay, again, this is not like a critical error. Emergency stop. Bruce, Bruce is a little bit busy at the moment. You okay, Bruce?
Yeah, sorry.
It's okay. It's okay, Bruce. I'll pick on somebody else. Let's go with Christopher. Christopher, when I say e-stop, what parameter do you think of?
Parameter?
If I say e-stop, yeah.
I don't really know. I guess.
Check your index.
Yeah, let me see.
We started today's class with, well, it was one of the first things anyway, not the very first thing, but it's in the 2000s, just to narrow it down a little bit and save a bit of time.
Okay, and what was it that you were?
Emergency stop. Emergency stop.
Yeah, I got it. It's 2109.
2109. So 2109, if that is active and you try to start it, or let's say you turn on your drive and your e-stop is pressed, or basically you're going from one lab to another lab where you had an e-stop, but then you took the wires off. It's expecting to get current in digital input 5, but it's not. It's going to give you this code here, 2023. E-stop. There's an e-stop issue. What do you do to resolve it? Well, you're going to go to 2109 and resolve the issue. Okay, change the input. If you're not using it, you put it to 0. If you've rewired it to another input, you put that input there. Okay, so this one here is pretty common. 2025. This is the one I told you. It's not really a fault. It's a code saying, hold off. I haven't started in a while. Sometimes it just does it randomly, and it's a first start. It'll perform the self-diagnostics, and then it's going to start. So basically, don't touch anything. Just wait. And that's why I put this here, and I expect you to write it down like this for your notes as well. Just wait 15, 20 seconds, it'll start. Okay. I know 2023, 2025, there's a lot of numbers. You start to panic a little bit, but don't worry. Okay. 2025 is not an issue. Okay, some alarms. So on page 260, we have 5011. Drive is controlled from another source. What does that mean? look, there's local and there's remote. If you look at the camera here, I'm going to show you the button. One little button right over here, if you can see it. What does it say? It says local and remote. So basically, that code is gonna be given to you if you're in local and you press a remote button, or vice versa. Right? Basically telling you, well, you're meant to be controlling me remotely, but you're pressing my buttons. Don't press my buttons. Okay. After that, 5012, direction. If you look at 5012, direction of rotation blocked or locked. Enable change of direction. So basically, kind of like 2004, but 2004 was more of a, I guess, like a wiring issue potentially. And 5012 is basically you're stopping it from going a direction, but you're telling it to go that direction. So 5013, panel control is disabled because of start inhibit. So often when you get the 2023 that we just talked about, you may also get 5013. Okay, they're linked. It's kind of putting emphasis on what the issue is. 5023 also pretty common, not critical, but it basically, if the motor is running and you're trying to change the min and max speed or some certain settings, it's not going to allow you to, and that's what it's saying. You can't change. Let's go see what it actually says exactly. Parameter change is not allowed when drive is running. So you press stop it, and then you can change that parameter. And then if you really mess up, you don't want to be seeing these ones here. So F0001 overcurrent, F0016 earth fault, F0021 drive internal fault. Not good. Fatal error. Change the drive. Fail the exam. Okay, that's in the following pages. So there's other ones too. Short circuit, really not good. Check motor cables. And that one's pretty obvious what that one is. Okay, earth fault. They're all in your book. So, I mean, you're going to have your index with you for the labs, but let's just say for the exam, you're not going to have that index. That index is just to help you out in for your labs. You're going to have a manual, and that you're going to have to get used to using the manual to program the drive. I mean, the drive can do a lot of things, but we're really looking at, well, I mean, from what we just learned, there's a lot of different applications, but there's even more. We're just looking at typically stop, start, forward, reverse using push buttons, selector switches, e-stops, quite a bit of control, but it can do a lot more. Okay, it can do something called proportional control as well, which we're kind of going to touch, but we're not going to get into it until we learn about instrumentation, which is module 23. That's not too bad. So now you've got the information needed to finish off the exercise that I gave you last week. We'll finish that off. We'll correct it. I'm going to elaborate on all the parameters that are basically brought up in that handout. And there's a couple of other subjects as well that I want to broach tonight. Are there any other questions? We're good. Okay.